Yeah. I don't, I'm sorry. I don't think so anyways. You can open it up on your phone if you like. It's on Moodle. It's under books and resources. It's on like the top. Yeah, it's like the second link or something.
It's one of the last links. It's with the
Is it? Okay, okay.
It's at the end.
Yeah, under books and resources. Are you writing stuff down?
I don't understand the second question.
Carry out your test, your p-value.
Sir, if we give you an expected result, sorry, if they give you, how do you know the difference between the chi-square test and p-value?
There's probably some situations where you could actually use both, but I think it should be pretty clear because binomial, I suppose the difference is this: binomial, you're counting the number of occurrences of an event which could only be either happening or not happening.
Okay.
Whereas chi-squared, you're counting the occurrence of a number of events which have multiple outcomes, like the bulb is yellow, or the bulb is purple, or the bulb is whatever, you know. So the key distinction between the two is, are you counting things that have two, or are you counting things that have more than two possible values? So here, it's two because it's either affected or not affected by the blight.
It's quite straightforward. You don't need to even go to the opposite.
Yeah, correct. Correct.
It's tricky.
Yeah, but this is the point I'm trying to make, young man. I think these questions, once you get your head around them, are straightforward and easy, even.
So for this one, it's the probability of 3 or less?
Yeah. Got an answer? Got an answer? Got the right answer? The right?
I need to take
What p-value did you get?
Yeah, so reject.
That's reject. Yeah. Yeah, that's reject. Yeah. Yeah.
my answer.
Nice.
Good.
No, you're getting yourself. You'll need to burn this into your brain. If it's less than 5%, reject. Null hypothesis. Yeah, for the p-value. Yeah. It's the other way around for chi-squared critical value.
So in terms of this question, the null hypothesis is possibility is 0.5. And we reject this.
No, it's like saying that you reject the null hypothesis, and there's a 5% chance that that was the wrong thing to do.
Wait, 95%.
What did you get?
It was the right thing to do. Yeah.
There is 95% chance
It's basically, you know, a lot of people say that, but if you're being a very picky statistician, you wouldn't say that. But you have the right idea that you've got a 95% chance confidence. We use the word confidence. There's 95% confidence in it. Okay, let's have a look here. I'll switch it now. So what is the null hypothesis here?
The substance reduced.
Yeah, and let's put it as a mathematical statement. So the probability of blight is 3.5. And the alternative? Less than 0.35. Okay? And just to be clear, where P is the probability of blight.
So when do we say that the alternative hypothesis is less than when do we say it's not equal to?
That is, so here we're testing that it reduces the blight. So that's one tail. But they could have said, test the hypothesis that the, what was it, this treatment, was it? has some effect. So in cases of some effect, we don't, yeah, any changes, yeah. So it could be just either way, so not equal. Okay, so let's calculate the p-value. So how many cases did we get in the observation? 20 and we observed 3. So what would be more extreme than 3? 3 or less. Now, this is amazingly simple, you realise, because there's nothing to fix. It's simply go to your table book, look up n is 20, p is
0.05.
and x is 3. And what answer do you get?
0.98.
0.0. What the fudge? 0.44.
4.
Roughly 0.04, which is less than 5%. And so, what is our conclusion? Yeah, we reject the null hypothesis. 6 marks. And I think we get a feel for how the marks go, don't we? It goes 1, 2, 3, 4, 5, 6. I think they might still give you the last mark if you don't, but it's good practice to say it. So we reject null hypothesis at the 5% level. Can you understand my frustration here? That this is actually not difficult, and you should be getting 6 out of 6 out of this, and it should be an easy question for you in the exam. Yeah? Okay.
Isn't there any exam question which the 2 cases?
Do you know, it's a good question. They do seem to prefer the one tail.
Yeah.
But we'll have a look at more now and see if we can find the two tail.
I find that the 2 tails is more difficult. With the
It is! It is more difficult. Let's see what we can find. Did I switch? Am I back on Moodle? Can everyone see?
No.
No, I have to switch it, sorry. That was version 1. Let's have a look at version 2 here. Here's the chi-squared one. Let's have a look at this one. I'll see if I can find it. Chillax. Right, so a spinner has 5 sides which score 0, 1, 2, 3 and 4. It's claimed that the spinner is fair. That means it's claimed that each outcome is equally likely. The spinner is spun 100 times and the results are shown below. So, no, it's a different one. It's a different one. We haven't done this one. How many times did we score a 0? 15. And so forth and so forth. Now, if you spin 100 times and it's supposed to be fair and there's 5 outcomes, how often should each outcome occur? 20. 20, yes. Yes. So, under or over? Under, over, a good bit under, a little over. So what do you think, guys? Before we do any calculations, is this consistent with the statement that it's a fair spinner? I think it might be. Yeah, I know this one is quite a bit out, but, 23, 25, 24, and 15, they're all within 5. They're all within 5 of the true value. And you only have one of them which is 7 away.
15 feels a bit off.
No, it's only 5 away. I think it might be still fair. We'll see what we get.
Which version is this?
This is the next one, version 2. It's 6b. Okay. Right, so again, I'll give you a couple of minutes to try this one. This one is easier than the one we did in class earlier today, and then easier than the one I did with the other group last time. The one with the ratio 1, 2, 3, 4. Why am I saying is it easier than 1, 2, 3, 4? Because you don't have to think about what's the expected values. If they're all equal to 20. Yeah. Okay. Try this one now for a minute. Good. Give this one a try. Okay, but you know, at least pretend you're working. No, show me that much courtesy. Thank you. I think this is an example where the most convenient way to state the null hypothesis is as a sentence, rather than as a mathematical statement. Yes. Hang on there. We're halfway through. Come on, give it a try. A bit of hypothesis testing now will wake you up.
You sure? What about the first one? Can you write as a sentence?
Yeah. In fact, I think it's easier to write as a sentence in this example.
Yeah. We're not back until Tuesday.
Yeah, I know. Thank goodness for that. Yes, indeed.
And
Expected and observed, yeah.
observed minus
Yeah, but it doesn't matter because you're squaring over expected.
So what's the degrees of freedom in this case?
What do you think it is?
It's 9.
No.
4.
4. Yeah.
I'm surprised that I figured that out.
Safra, are you trying this? Are you trying this one? Hmm?
The first class was strange.
Don't worry, you're getting there. You're looking at your chi-squared? Are we ready to see this one, or we need a minute?
Just
One more minute, one more minute. One more. Okay, let's have a look. So, what is the null hypothesis here? It's a fair spinner. And the alternative? That's not. What is the expected frequency? 20, 20, 20, 20, and 20. Carry out the chi-squared test. So remember, the chi-squared is the difference between what was expected and observed squared over expected. So it's the difference between the first one is the difference between 15 and 20, which is 5 squared, which is 25 over 20. Actually, do you know what? They're all over 20, so let me just put, have I got 5 of them yet? 1, 2, 3,
The other one's
4.
4 squared.
Right. So the other one is 4 squared,
Yeah.
5 squared, 49,
Yes.
and 9. Right, what does this come out as?
6.2.
Ooh, that's close. That's close. Because it's like, what's it, like 6.25 in the book or something?
Yeah.
I don't have the book in my brain, so...
0.5.
Okay. Thank you. So what's the degrees of freedom here?
4.
4 degrees of freedom. And did they say 5%? They do. Oh, it's much higher than I thought. 9.49.
It's fair.
Anyways, it doesn't matter because it's still less than it.
So we do not reject.
So you do not reject. Which is what I taught at the start anyways, remember?
It's 4% degrees of freedom.
If you use the
4, yeah.
4 and 0.5%.
if you use the binomial hypothesis to examine the 4 or 3,
Yeah, 7,
it's
0.
likely to be unfair.
Why did you reject
Good
it?
question. Use the binomial here.
Yeah. It's just weird. Never mind.
No, I like it. The only problem, Young Peng, is we can't use the binomial here because our binomial table only goes up to 30 and this one is 100 trials. Yeah, unfortunately. But I could kind of imagine a way how you could do this as a binomial problem. Guys, if we want to think about this as a binomial problem, we'll have to restate the problem slightly to make it binomial. Because right now, your outcome on your die, your spinner, is one of 5 possibilities. Whereas with a binomial, it should only be one of 2 possibilities, like flipping a coin. So how could we restate this problem to make it binomial?
Cut it in half. Side below to above.
You could do something like that, but unfortunately, because, no, that would work, but unfortunately the die has 5 sides instead of 6. So if it was something like 6, you could do that. So we'll need to do something else.
Why wouldn't it work with 5?
Yeah, because you can't.
You can't,
Oh yeah.
Half of 5 is what?
yeah,
2.5 times.
yes. So, what could we do? Yeah, you could say something like, if it's fair, then the number of even numbers that appear should be the same as the number of odd numbers. Although we have 0 here, so we could exclude 0. So I said, except for 0,
How is it a 5-sided die?
it's a 5-sided spinner.
Oh.
Except it's with that thing you turn. Yeah. So you could say, as a binomial, excluding 0, the probability of getting an even and the probability of getting an odd should both be 0.5. Now let's actually have a look here. We won't do this one because we can't, because it's too big, it's 100. So how many odd numbers did I get? I got 30, yeah, in total it was, sorry if I switch, 37? And then how many evens? It was 25 and 23. What's that? 48. Yeah? They're supposed to be equal. You could imagine this as being like a coin question now, where you flip a coin and you say, I got heads 37 times and I got tails 48 times. And the null hypothesis is that it's fair. And then this one here, Angela, with the alternative would be unfair. So this would be two-tailed. So the p-value, now can someone add those two together? What do we get?
85.
Is it 85? And half of 85 is 40. 2.5. So if it's fair, we should have gotten about 42 heads, but we only got 37. So what would be more extreme than getting 37? 37 or more, or 37 or less? 37 or less. That would be more extreme. Yeah?
So we don't have to take
Exactly. So we'd have to stop here, because we can't, we've reached a limit, because our tables only go up to 30. But my point is, was it you, Angela, or Young Peng? Someone was asking me, can you interchange? No. Like when to use binomial, when to use chi-squared.
Oh yeah,
Yeah.
that was me.
Yeah, but there are some, you could restate the problem so you could actually switch between the two.
It's unlikely to use binomial in two-tailed question.
No. Oh, in the exam, yeah, it's unlikely. It tends to be one tail. Let's have a look at another exam one here. So that was version 2. Let's go to version 3.
That one was B6, yeah.
Yeah, it was the last one.
Isn't there a way to go beyond?
Oh, sorry, just before, and don't forget, this is two-tailed, so we would have to have the other end.
Yeah.
Yeah.
So that's 37 heads or less, and then the other extreme would be 37, yeah, or you could say it as 37 tails.
What?
But if you prefer to state it as the reverse number of heads, whatever 85 minus 37 is, what's that? 30.
Yeah, 14.
Oh yeah, of course it is, sorry. 48 or more
Yeah.
heads.
That's how we did it.
Yeah, that's how we did it.
Yeah.
Yeah, that's how.
No, what were you doing with the 37?
Huh?
You were going to do 37 or
Oh, I was going to change the statement of 48 heads or more
Yeah.
as 37 tails or less, to make it easier to look up in the formula book.
Oh, so you will just have it as
Two less tans.
2 times of okay.
In this case, it will be 2 times, yeah, because it's symmetric. Yeah, because the probability should be no, because the probability here is 0.5. That's what allows us to do that. Okay, let's look at another paper, version 3. I'll start at the bottom since it seems to be where it is.
There it is. You went past the paper.
No, A,
B6
A.
Good. Can you see?
No.
3 and 4.
Can't see.
Which one is this?
Version 3 now.
We have to answer.
So, yeah,
This one's a hypothesis.
the second part is,
We still have to find the probability.
now this question here is quite nice because it's a hypothesis test and it's a binomial. When a certain type of seed is planted, records show 45% of seeds fail to germinate. A sample of 15 seeds is taken. Find the probability that exactly 7 fail. So what do we do here?
7 or less.
No. This is not a hypothesis test one. This is 15C7. P7.
C. Why P?
Point. Okay.
0.457.
Yeah. 15 C7.
Yeah, C.
C. Yeah. Oh, is there an echo in here? 15 C7. 0.45 power 7. 0.65 power 8.
5 times 0.5.
What is it? 0.55, thank you. Now, find the probability that 9 or more fail to germinate.
I got 0.76.
Ah,
Doesn't that mean
It's
6 or
6
less?
or less.
9 or more seeds fail to germinate. Yeah, so what are you telling me?
6
1
or
minus
less
6 or less.
germinated.
6 or less germinate, yeah. Yeah, so you just have to go to the formula book. N is 15, right?
Yeah.
P is,
0.65.
no, 0.45 is germinate, isn't it?
Yeah, we need to go opposite way.
Yeah.
Yeah, because we
Yeah, but no, it says fail to germinate. Oh, sorry, so we said germinate.
Yeah.
6 or
Yeah.
6 or less germinate. So it's zero.
So I actually think it would be easier than to say 1 minus the opposite of this.
Yeah.
So instead of saying 9 or more,
One
you
minus
should
six
say
less.
8 or less.
But we don't have a 6.5 value.
Well, 1 is 8.
Yeah, but failed to germinate is 0.45.
Why is 8?
No, not this again. Right. No, nobody talk and just listen to me. Listen to my actual words. Okay? So if I say to you 9 or more, the opposite of having 9 or more of something is having 8 or less of it. Okay? If I say to you, you have 9 cats or more, what is the opposite of that? Having 8 cats or less. Right? So let's not be ridiculous here. So this will be 1 minus 8 or less. Okay? Okay? N is 15, P is
0.45.
0.45, and X is 8, and the answer is?
0.818.
There you go, okay?
Boom.
Why is
Ah.
8?
Come on, just read the blooming table in front of your face.
Right here.
Right, let's see who I'm slapping. I'm seeing who I'm slapping now. Wait. Hey, hey, I want to see who gets slapped. What did you say the answer was? You retract your answer, do you? N is 15, P is 0.45, and what did I say X was? 8. 0.8182. Congratulations, you can read.
But should we use 1 minuses?
And then 1 minus that, sure.
0.18.
Yeah, but I was asking what the table value was. Okay. Right. So, the next one here, can you see it?
Yeah.
Question? A seed merchant claims that its seeds have been treated with a chemical compound which reduces the germination failure rate. You see, everything here is exactly the same. It's only one difference. What is it? The 10% level. Yeah. So, let's open up version 4. This one here, chi-squared, and it's a ratio one. 325. 325. Just like the one we did earlier today. Okay? Huh? Let's look at 1516 now, version 1.
This is before, after they changed it.
I think this is when they changed it, perhaps. I'm not sure. Let's see. Chi-squared version 1. It's exactly the same as the die again.
Yeah.
It's a 4.
No, that one's a 5.
That said 1, 2, 3, 4. Doesn't matter. It's the same one. This one here is null hypothesis test. Null hypothesis test. Interesting. Version 3. Oops. Version 3. Let's see. Hypothesis test. Yeah. Chi-squared 1, 2, 3, 4. 200 seeds. Okay. You see there's repetition here. It's almost like you can prepare for this. Okay.
Or we could sleep.
And actually, it says here, Angela, it does actually say 1 tail, so there's no confusion as well.
I just want to see an exam style.
Of 2 tails. I think what we might have to do, in the old syllabus, the business students had hypothesis testing, and they had binomial hypothesis testing. So we might be able to get one exam style 2 tail from one of their papers.
Do we do the same exam as the business and engineering?
No, it's different.
That was the one of the same.
We have more statistics, right?
Yeah.
Probably have more calculus.
Who?
Business.
No, engineering probably have more calculus. Engineering probably have more.
can find one for you.
Sounds likely to have not just had a question.
Ah, here we go. Right, let's have a look at this one. Now, we'll skip part 1, 2, 3 because, oh, you guys won't have access to this because it's on the business page. So, yeah, if you wanted to take a picture or, but sure, this video is recording so you can hear me say this question here, okay? We're going to skip part 1, 2, 3. Look how many marks are for the binomial hypothesis testing. 6. You see, it's consistent. It's 6 marks for doing this, okay? Each week, a butcher expects 45% of his customers to buy beef. A random sample of 10 customers is chosen each week. One week, there's a health scare involving cattle. How many of the 10 customers in the random sample the following week must fail to buy beef in order to convince the butcher that the health scare has had an effect on his sale of beef? So this is the question where we'll do it here. Remember, we did one like this in the worksheet. It's where you want to find the levels that will cause the p-value to fall below 5%. But first, before we do that, what is the null hypothesis here in my story? And I can switch back if you need me to.
0.44.
Yeah, that the probability that you buy beef when you go to the butcher's is
0.45.
0.45. And the alternative?
Less than.
Not equal.
Now, this is a very good question. I'll put the story back up and I'll ask you to read and decide.
Less than.
So, what choices we have to make? It seems like you're deciding it's either going to be this, or some people might think,
Switch.
oh yeah, I will, sorry. Some people might think it's the other one. So, what are we thinking? What are we thinking? Any strong opinions on which it would be?
Less.
Actually, no, it isn't equal because it says any effect. Not
Yeah,
equal.
there's two problems here, okay? Firstly, they said any effect. So from just the plain reading of the English, you would go with this one. However, you could object and say, well, hang on, I know it says any effect, but let's be realistic here. They're talking about a beef scare. So clearly what they had in mind was that the sales are reduced. Now, which one it is not entirely clear, and it's up to the person doing the test to make a decision.
Well,
I'm kind of very picky about my language, so I actually would opt for this one because I'm picky about the language. They did say an effect. They didn't say a detrimental effect. They just said an effect. Now you might say you really want to test that people will buy more beef during a beef scare. I'm like, that's what it says. Yeah.
Would no effect be an effect? It's not an effect. Nothing is happening. It's not changing.
Huh?
What?
No. Just no. I'm continuing with this. Okay. Right.
But it doesn't make sense.
Yeah, I don't know. It doesn't make sense to
Yeah,
me.
we don't want to be inventions.
I think we're too tired.
Yes.
No, but from what they've given us, we don't have to think too much about it. They just told us any effect.
They just said an effect. Yeah. Correct.
So it's not.
Correct. Now, I kind of feel like whoever wrote the question wasn't fully thinking that, and the market scheme probably will be one tail. But you can't do an exam thinking what was the guy writing thinking. You just have to answer the question as you see it. So I'm answering it as I see it, which is two tail. Okay? Yeah.
So if I did answer how I saw it as two tails,
Yeah.
and the market scheme said one tail, would I still get the mark?
It's up to them to decide.
Anyways, the answer will be more than.
Yeah, well, let's see. Because the example I did in class, I think it didn't matter which one it was, because it was the same result either way. So let's see what happens here, okay? So we have 10 customers. How many customers is he expecting to get buying beef if there's 10 customers and 45% buy beef? So obviously that's not realistic, but we'll just mark off 4.5 here. Okay? So anywhere near 4.5 is supporting the idea that there's not really been any change. Okay? The extreme here, and by the way, I'm choosing to go for this one, is if quite a few number of visits or an increased number. So there's some point here where the p-value becomes 5% or less. And we will put 2.5% here and 2.5% here. Okay, and we try and work it out. So we want to, I'll get this guy first, I'll call that guy x. Okay, so we need the probability to be the number of sales to be less than some number so that the answer is 0.025. Okay, so we have to go to our table book. Yes, we have to pick n is 10, p is 0.45, and we need to look for an x that will give us 0.025 or smaller.
It goes from 0.099 and then it goes to 2.266.
Ah.
Yeah. It jumps.
It jumps a lot, does it? 4, 5, and you have to pick one because the jump is so huge.
Yeah.
You have to pick one. So the answer here is 1 for that side. Sorry, I mean to say more or equal 1. Sorry. Now, let's look at the other side here. So we need the number of sales to be more than or equal to some number so that the total here is 0.025. Can we do more than? No, so we flip it around and do 1 minus probability that sales is less than some number equal to 0.025. So that means the probability that the sales is less than some number that's equal to 0.975. Okay, back to our tables. N is 10. Is it? Well, let me see. N is 10. 0.45. 979? Where's that? Ooh, I have a 9726. That's the closest, isn't it?
Yeah.
That's a 7. Isn't it?
Yeah. Less than 976. Yeah.
7. So, if that's a 7 and that's a 7, then this one here was an 8. Remember? The cats? Yeah. So, this number here is 8 and this one here is 1. So, if he gets 0, 1, 8, 9, 10 sales, then he rejects the null hypothesis that there was no effect. Right, it's an A, isn't it? Or an E? An A, yeah. Rejects the null hypothesis.
Easy. No effect.
Affect is
No, I know that. I'm just getting confused about which one to use. Is affect affecting the sales?
Yeah.
Or effect as there's, yeah.
Effect.
Yeah, but depending on how you use it, I think you could use either here.
There's no effect on.
Yeah, that's how I was thinking originally, yes. Doesn't matter. Doesn't matter.
Can we just finish?
Wait! Let's just check the marking scheme before we go to see which one did. Dude, would you just calm yourself down?
They're gonna use the left one.
Stop
I bet
torturing
you.
us, please.
It's not torture.
Please.
I will never agree with you before.
This is what I hear right now. Wah, wah, wah. I don't want to succeed in maths.
Not right now.
Can I have my table?
Yeah. Before,
Switch.
so they went with just one tail. Did they? Yeah.
Knew it.
I can see the website.
When the people who wrote the exam.
But
they want.
they went with one tail, but the answer was the same.
When they went with less than,
Yeah, they would say that they would need to get 0 or 1 sales to reject.
By 8 or 9 attendance. You didn't take attendance.
So that's
No, it's only one.
So is it because it's symmetrical that we get?
No, they did 1 tail in the marking scheme.
Oh, yeah, just the
Yeah.
so,
Yeah. But it was the same value on the left tail.
so is it always like that? Like,
Oh no, definitely not. It's just the examples we've done so far by just weird coincidences worked out like that. But in fact, it's usually the opposite. It's usually not the same answer.
So
Wait, I just need to do the attendance before you
you get
go.
0 for all that work.
I don't like that.
Do we overthink it in the exam and just, or do we just go for what?
No, just read it plainly and do it. You can't be thinking about.
So reading it, then you didn't give us the right answer.
I know, but that happens with other questions too.
Just don't pick a color.
No,
What did the student
Yeah, but look, how likely is that to happen? I had to go back to 2010 to find a situation like that. Okay, so let's just have a grip on reality for a moment. Mahmoud?
Yup.
Gafar? No.
Yes.
Amjad, yes. Zara? Mo?
Yes.
Daniel? Sabi? Sabrina? Alfreda? Aria? Chidi? Yungpang? Amna? Mariam? Michelle? Abir? Awesome? Celine? Sophia? Mubarak? Shadira? Mohammed? Sabrina? Moza? Angela? Ahmed? Safra? Neil? Yeah, I got you.